we are going to continue with our marking scheme for Senior 3 end of year assessment, which came from Wakissha. I will first apologize for not completing this scheme on time. Yeah, I had some challenges, but I uploaded 2 questions I think in December. Yeah, now I'm going to finish to wind up with the other questions. Now we have this question. This question came from the chapter of carbon in life, and it was concerning how ethanol can be prepared on a large scale. So the question: during the lockdown, Mr. Kaima organized a house party and served alcohol, in brackets ethanol, which was made by fermentation process. So they started drinking from morning, but unfortunately the alcohol got over and all the bars were closed. They asked the village members the substances used to prepare alcohol, and they were told it's either starch or sugar. So that is the body of the question. Kaima organized a house party and served ethanol. Unfortunately, ethanol got over, and they realized that they can prepare ethanol from starch or from either starch or sugars. So, but if you were one of the invited guests, which 2 substances would you look for in the community that can be the source of Roman 1 starch, Roman 2 sugar that can be used to prepare ethanol? So they want you to identify substances which can work as source of starch and also as source of sugars. So let me hope that you've taken note of this question, this model. So part A, we have, they want sources of starch, source of starch. So you can extract starch from carbohydrates. Example, cassava and sweet potatoes. You can extract starch from those substances. Then also they want sources of sugar. So we can get this from sugar canes and sugar beets. Then you can also use ripe bananas. There are some of the sources of sugar. So that is part A. Now I can get rid of this. Part B. As a chemistry student, how can you prepare ethanol by fermentation? That is part B. Part B. As a chemistry student, how can you prepare ethanol by fermentation of starch so that the guests can continue enjoying? So how can we prepare ethanol? So they want us to prepare ethanol from starch or sugars. Now, we want to prepare ethanol. I want you to make use of this acronym. Now, before we evoke the acronym, First of all, let me first note the raw materials. The raw materials we shall need. Raw materials we shall need. We shall need starch. Then we shall need malt. Then we shall also need yeast plus the heating source. We shall need those raw materials. Now, after identifying the raw materials required for preparation of ethanol, we can make use of an important acronym. But before I evoke that acronym, first of all, we need to know the constituent of this malt and yeast. These are the raw materials. So this malt contains enzyme diastase. You can note it down. So this one contains enzyme diastase. Then yeast contains two enzymes. It has maltase and zymase. Now we are going to discuss the use of those enzymes. So we are going to make use of this acronym SMG, then E. That important acronym. So this S stands for starch, M stands for maltose, then G stands for glucose, and E stands for ethanol. So we are going to first convert, in simple terms, we are going to first convert IE, that is to say, we are going to convert starch to maltose. And after converting starch to maltose, we convert this starch to maltose to glucose. Then after, convert glucose to ethanol. Now, once you understand this acronym, then you can easily describe how ethanol can be prepared by fermentation. So you need this. S stands for starch, M maltose, G glucose, and E ethanol. So you convert starch to maltose, convert maltose to glucose, then glucose convert it to ethanol. So within this process of converting starch to maltose, or carrying out those conversions, we shall need some things to facilitate the conversion process. So what can we start with? So we are going to start with our starch. So this is the required procedure. This is just for purposes of understanding. The required procedure, we start with our starch or sugars. So we are going to say that this is the procedure. You paragraph your work, kindly paragraph your work. So starch is heated. Starch is heated with malt. Starch is heated with malt to about 60 degrees Celsius. It's heated with malt to about 60 degrees Celsius. So malt contains enzyme. It contains enzyme diastase. It contains enzyme diastase, which hydrolyzes or breaks down contains enzyme in this spelling is wrong, contains enzyme that says which catalyzes the hydrolysis, of starch to maltose. So you convert starch to maltose. You convert starch to maltose by adding malt. So to carry out this process, you add malt. What is the importance of malt? Malt contains enzyme diastase, which hydrolyzes starch to maltose, Now we have converted starch to maltose. We need to convert maltose to glucose. We need to convert maltose to glucose. But before that, we can write the equation for this. The equation for this, we are converting starch to maltose. This is the word equation by adding malt. This is the word equation. Now the chemical equation is this is the word equation. The chemical equation is the formula for starch is this. So starch is converted to maltose. So we are going to add water. Why are we adding water? Because malt contains enzyme diastase, which catalyzes the hydrolysis. This word hydrolysis means the process is carried out in presence of water. Hydrolysis. Yeah. The enzyme acts in presence of water. Then we shall form our maltose. So this is our maltose. So that is the equation. This is aqueous. Also this is liquid. This is aqueous. You can check and see whether it's balancing. This is 6, this is 12. Maybe you can put a 2 here. If you put a 2 here, this is 12. Also this is 12. 10 times 2, that is 20, plus 2, 22. Also this is 22. Oxygen 10 plus 1, 11. Also this side 11. So it's well balancing. Now we can proceed to the next step of converting maltose to glucose. So maltose, yeast is added to maltose. Yeast is added to maltose at room temperature. Yeast is added. So to convert maltose to glucose, you have to first add yeast. It's added to maltose at room temperature. What is the importance of that yeast? So yeast contains two enzymes. What are those enzymes? It contains enzymes maltase and zymase. So maltase catalyzes the breakdown. Maltase catalyzes the breakdown of say it catalyzes the hydrolysis. Catalyzes the hydrolysis. Catalyzes the hydrolysis of maltose. Maltose to glucose. So yeast is added because it contains two enzymes, maltase and zymase. So one of the enzymes, which is maltase, breaks down this maltose. Remember, this was our maltose to glucose. So we are going to convert maltose using enzyme maltase. Using enzyme maltase, we can convert it to glucose. We can convert it to glucose. So this is the word equation. Now we can write the chemical equation. The chemical equation, I'm continuing. Up. So maltose, the formula for maltose is C12H22O11 plus water. I told you that we are adding water because we have maltase catalyzes the hydrolysis. The hydrolysis means reaction with water. So this enzyme acts on maltose in presence of water. So we shall convert now this to glucose. CH4, 6. This is aqueous, liquid, aqueous. And we can put a 2. I think it's not balancing. We can put a 2 where maybe we can put a 2 here. This side we are having 12. Also here 2 times 6, 12. Hydrogen 22 plus 2. Those are 24. 2 times 12, 24. Oxygen 11 plus 1, 12. Then 2 times 6. That is 12. So now we have converted maltose to glucose. We are left with converting glucose to ethanol. Remember, our yeast had 2 enzymes. So one of the enzymes, which was maltase, we use it at this stage of converting maltose to glucose. Then the other enzyme, which is zymase, we use it in conversion of glucose to ethanol. Yes, in conversion of glucose to ethanol. Yeah. So here, at first we said that here we need enzyme diastase. Don't forget that enzyme diastase. Then here we need enzyme maltase. Then here we need enzyme zymase. Don't forget this acronym and these 3 enzymes. We convert starch to maltose, maltose to glucose, glucose to ethanol using these 3 enzymes. We get this enzyme from malt. Then we get these 2 enzymes from yeast. So we are going to continue with our procedure. We want to convert glucose to ethanol. So zymase from yeast, breaks, catalyzes the breakdown of glucose to ethanol and carbon dioxide. Catalyzes the breakdown of glucose to ethanol and carbon dioxide. Carbon dioxide. So the word equation here, we need to convert what? We need to convert glucose. We need to convert glucose to ethanol using enzyme zymase. I'll convert this to ethanol using enzyme zymase. That is the word equation. The chemical equation, we have CH12 or 6. I'll convert this to C2H5 OH and plus carbon dioxide. Also heat is involved. This is an exothermic reaction, but you can ignore this heat. Yes, but that I've just added it to show you that the process is exothermic. Heat is given out. So we can balance. How can we balance this equation? Maybe we can put by the way, for enzyme zymase we don't add water. This is not hydrolysis of glucose. Yes, this is not hydrolysis of glucose, so it's simply that. Now we need to balance this equation. How can we balance it? Maybe we can put a 2 here and also a 2 here. We're having 6 carbon atoms. Here we're having 4. 2 times 2, that is 4. Then plus 2, 6. Hydrogen 12, 2 times. So here we're having 2 times 5. Those are 10. Then also 2 multiplies here. 10 plus 2, 12. 2 times 5, those are 10. Then plus this one, 2 also multiplies here. So those are 2. So we have 10 plus 2, 12. Then also here, oxygen there are 2 plus 4, 6. Also the other side there are 6. So that is the equation. Now we have got our ethanol. So you continue and say that ethanol obtained can be purified by fractional distillation. Yes. You don't need to explain the process of fractional distillation because the question only required you to prepare ethanol. Now, if the question required you to prepare and purify, then you also explain the process of fractional distillation. But this question only required us to prepare ethanol. How can we prepare ethanol? We can prepare it from raw materials. Don't forget the raw materials are starch. We need malt, yeast. These are the fundamental raw materials. Yes, the most important ones. Yes, the fundamental ones. But also the beakers are also required. Yeah, maybe since this is at home, maybe you need the saucepan, such things. Yeah, but these are the fundamental ones. So you need starch. You convert starch to maltose, convert maltose to glucose, convert glucose to ethanol. So how can you convert starch to maltose? You need to add malt. What is the importance of malt? Malt catalyzes the breakdown of starch to maltose because it contains enzyme diastase. Then after adding malt, then also add yeast. Yeast will convert maltose to glucose. Yeast contains two enzymes, maltase and zymase. Maltase converts maltose to glucose. Also zymase converts glucose to ethanol. So that is the required, that was the required procedure. So let me hope you taken note of part C. Yes, part C. Part C, they wanted you to identify some of the uses of ethanol apart from being consumed as a drink. Yes, they want uses of ethanol apart from drinking it. So what are some of the uses of ethanol? We can use ethanol. They wanted 5 things. Yeah, they wanted 4. So ethanol acts as a source of fuel. Ethanol can be used as a source of fuel. When you burn ethanol, ethanol produces carbon dioxide and water, and that process is exothermic. So one of the major use of ethanol is that it can act as a source of fuel. You can put it in what? How do they call those local things which produce light? You can put, in Uganda we call them turnovers, but I don't know how they call them in English. Those things which produce light. Yeah, you can also use it to burn certain substances. Yes. Yeah. So ethanol acts as a source of fuel. So the other thing is that we can use this ethanol as ethanol acts as a preservative, which prevents things from going bad. For example, you can kill your cockroach. Now, if you want to preserve that cockroach, if you want to maintain the nervous system of that cockroach in the stable way, or if you don't want it to rot, you can add ethanol to that cockroach. You will preserve it. In fact, it is used in most of the laboratory to preserve dead insects. Yes. So ethanol can also be used. Ethanol is used to manufacture paints. Ethanol is used in synthesis. Ethanol is used in synthesis of organic compounds. E.g., you can use it to make vinegar. You can also use it to make ethene. etc. It can be used to synthesize many organic compounds. Mention but a few. So I think now we can pause it that stage. Yes. So we have attempted part A, B, and C. We are going to proceed with the other questions.